Alright, in this video here we are going to be talking about an application of a linear equation, which means doing a word problem that involves a linear equation. Alright, so we have a swimming pool that's being filled with a hose. The water depth y in feet, t hours after the hose is turned on, is given by the equation y equals 1.5 t plus 2. Alright, so when you're doing a word problem, a couple important things. First thing, obviously, if they give you an equation, you need to be aware that that's the equation. But don't just take the equation and say, okay, here's the equation, let me just start doing stuff with it. You have to understand what that equation represents. Right? The y here, that this equation is equal to, is the depth in feet, right? We're filling up a pool with water, so the y represents how deep the water is in the pool as it's being filled up. And the t represents the number of hours, the time that's going by since we started filling the pool until the present time. Right? So y equals 1.5 t plus 2. And what we're asked to do first is to find the slope and the y-intercept of the graph of that equation. Right? So if I want to find the slope and the y-intercept, basically what I need to do is identify what that equation is. Right? So y equals 1.5 t plus 2, that is a linear equation, and I know it's linear because my variable y is raised to the first power and my other variable t is also raised to the first power. So when both of my variables are to the first power, I've got a linear equation. As long as those variables are not like in the denominator of a fraction or anything, that could change things. But if I don't have any fractions there and they're both to the first power, then I've got a linear equation. Alright, so I know I have a linear equation. Now the question is, what form is that linear equation in? Well, it's y equals 1.5 t plus 2. That's in the slope-intercept form, right? The slope-intercept form, y equals mx plus b. In this case, we have a t instead of an x as a variable, but the t just kind of takes the place of the x there. So I recognize that this is the slope-intercept form, which means my slope, m, is equal to 1.5, right? That's the number attached to the variable, the t in this case. And my y-intercept is that constant at the end, which is the plus 2. Right? So if I were to graph this equation, it would have a y-intercept of 2 and a slope of 1.5. I have now identified the slope and the y-intercept of this linear equation, or of the graph of this equation. Right? So anytime you have a linear equation and you're asked to find the slope and the y-intercept, if you have the equation already put together, like we have here, just make sure it's in the slope-intercept form, the y equals mx plus b, and then you just pull the numbers out of that equation. The m is your slope, the b is your y-intercept. You don't actually have to do any calculations or plug numbers in or use the slope formula or anything like that. The numbers are right there as long as you've got the y equals mx plus b form, which is what we were given to begin with this time. Alright, so we found our slope, we found our y-intercept of the graph of this equation. We're not asked to graph it. If you enjoy graphing equations, by all means go ahead and draw a graph of it. But that's not what we're being asked to do here. Part B asks us, what do these things represent? What does the slope and the y-intercept represent? Alright, so whenever you're doing a math problem and it asks you, what does the slope represent? Or interpret the meaning of the y-intercept or some words to that effect. It's asking you to not do math, like write down numbers and solve equations. It's asking you to actually write out some words of what this actually means. Right? So what does it mean that the slope of this is 1.5? Right? And don't say, well, that means that for it rises 1.5 every time it moves over 1. Right? That's what the slope means when you're talking about the graph. Don't say the y-intercept is 2. That means that the graph crosses the y-axis at y equals 2. Yes, that's what the y-intercept of 2 means in terms of the graph. But we're asking what these things represent in terms of this problem of filling up a pool with water. What does it mean that the slope is 1.5 and the y-intercept is 2? What does that mean in this real-life situation here? Well, every time you're trying to interpret or say what something represents or give the meaning of something that involves the slope is always going to be your rate of change. Right? It's the rate at which something is changing. Right, so, and that corresponds to when you actually draw the graph, how steep the line is, well, that's how quickly it's changing. The steeper the line, the higher the rate of change, the less steep the line, the lower the rate of change. Right, so the slope is your rate of change, and in this case, it's the rate of change of the depth of the pool, or the depth of the water in the pool, as the hours go by. Right, so basically what we're saying here is that since the slope is a positive 1.5, the depth of the water is increasing, right? As this hose is filling up the pool, the water is getting deeper and deeper, right? So my water depth is increasing and that bears out with a positive slope. If the slope was negative, that would mean that the water level was actually decreasing. We would be like pumping water out of the pool, right? So the slope is the rate of change. So it tells us that the water level, or the water depth, let's say, is increasing, right? Since it's a positive slope, I use that word increasing. If it was a negative slope, I would say it's decreasing. So it's increasing at the rate of, right? So again, the slope is always giving us the rate, and it's increasing at the rate of 1.5. But then what units do I use on that, right? Remember, the slope is the rate of change, and the formula for the slope, y2 minus y1 over x2 minus x1. Right? It's the difference in y values over the difference in x values. So if you're ever not sure what units to put on your slope, it's always going to be the y units per the x units. Right? So it's y per x. Right? Just like the slope formula is the y per the x, that's the units you get. So my y units are in feet, so it's 1.5 feet per my t units, which are hours. Right, so what my slope of 1.5 represents is that the water depth is increasing at the rate of 1.5 feet per hour. Right, so for every hour that goes by, we have 1.5 more feet of water in the pool. All right, so that is what my slope here represents. Right, again, slope is always going to be the rate of change. Right, whatever it is, in this case, it's the depth of the water that's increasing as time goes by. Right. The units are always going to be y per x, so it's the y units feet per the x units hour. Always the way it's going to work out when you're dealing with linear equations that deal with real-life situations. Slope is always the rate of change. All right, so then what does the y-intercept equals 2 represent? Well, what does the y-intercept mean? If I were to graph this equation, which I just said a minute ago, we don't have to graph it, but just to kind of make a point here, right? The y-intercept of 2 means that when t is equal to 0, my y, or my water depth, is 2 feet, and then the slope of 1.5 means every time I move over 1 hour, the water gets 1.5 feet deeper, right? So that y equals 2 as my y-intercept, that's my starting point, right? That's my initial value, right? So when I first turn on the hose, the water is already 2 feet deep. Right? When t is equal to 0, if I plug in t equals 0, I get y equals 2. So when I first start filling up the pool, there's already 2 feet of water in it, and then it increases at the rate of 1.5 feet per hour after I turn on the hose. Right? So if I can find some space up here to write this, and maybe I'll just kind of erase this to give some space. So I'll say initially, there are 2 feet of water in the pool. All right, so that's what your y-intercept is always going to represent, not just for a linear equation, but for any type of equation that you have that's related to a real-life situation. The y-intercept is always going to represent that initial value at t equals 0 at the very beginning. That's what the value was. All right, so if my y-intercept was 2, that means when t is equal to 0, my water depth is already 2 feet. Right, so the y-intercept is always giving you that initial value, right? We're starting at 2 feet, and then the slope is giving you the rate that value is changing as time goes on, right? The water depth is increasing at the rate of 1.5 feet per hour. So that's how you interpret the slope and the y-intercept for a linear equation, right? And it's always going to be that same basic way, no matter what the problem is talking about, right? This one's talking about water filling up a pool. But no matter what it is that's changing over time that has a linear relationship, that y-intercept always represents your initial amount. The slope is always going to represent the rate of change. And the units for the slope is always going to be the y units per the x units. In this case, feet per hour. All right, so that's an application of a linear function, interpreting that, taking the mathematical information we have and actually writing it and describing what it means. A lot of students are like, well, I'm in a math class, why do I have to write a sentence? Why do I have to put words together? Right? Sometimes that's important in math, right? You can be like the smartest mathematician out there, but if you can't express to other people in words what you're doing, nobody cares what you're doing, right? So, part of math is solving problems. Another part of math is communicating the solutions that you get, which is kind of what we're practicing doing right here.